Okay, so for today, we're going to be talking about factors and prime factoring. So when we talk about factors, factors are really just two natural numbers that when multiplied together can make another natural number. Or another way we can think about it is a factor is a way to express a natural number as a product of two natural numbers. So as an example, let's say we have our number 10 here. So we have 10. And 10 can be represented as the multiplication of 2 times 5. And in this case, 10 is our natural number, and 2 and 5 are two factors of 10. Another way we can look at it is 10 is also a factor of, 1 and 10 are also a factor of 10. So 1 times 10 gets us to 10 also. The equation way, or the definitive way we think about this, and I'm going to go ahead and type this out, is that to factor a natural number is to express a natural number as a product means multiplication in this case, of two natural numbers. Okay. So to factor a natural number is to express a natural number, that natural number, as a product of two natural numbers. Another example we can look at is 24. So if I want to factor 24, right? 24 can be factored as 6 times 4. Because 6 and 4 are two natural numbers, such that when you multiply them together, you get the natural number you're looking for. So 6 times 4 is 24, therefore 6 times 4 is a factor of 24. There's also another set too. Another set that makes 24 is 12 and 2, right? Another set that makes 24 is 3 and 8, so on and so forth. When we're talking about factoring, there's usually not just one factor set that works. A large amount of numbers have multiple factors. Okay. And so the next thing we're going to talk about is factor sets. So a factor set, I'm going to go ahead and type this out. A factor set, actually I don't need the capital S, I'll just do that, is the collection of all factors of a natural number. Okay? And so if we think about the first number we started with, which was 10, right? The factor set, represented by these curly brackets here, would be 1, 10. Sorry, I'll actually remove the 10 here. I was going to write 10, but I'll put it in order. 1, 2, 5, and 10. Okay? And so this is the collection of all factors of a natural number. So when we think about 10, 1 times 10, and I'll put this in, highlight this in red, 1 times 10 gets us to 10, and 2 times 5 gets us to 10. We're just looking for the factors. We're not saying that, well, does 2 times 10 get us to 10? Because that gets us to 20. That's not what we're looking at. We're not looking at this relationship at all. So we're going to put an X for that. Or we're saying, well, 1 times 5 doesn't get us 10. We're looking just for the factor set, the factors that, basically every factor that can get us to 10. So 1 and 10 get us 10, 2 and 5 get us 10. We don't care about 2 and 10 or 1 and 5. Those don't work. We just care about the sets that do work. Okay. Another one that we can look at, if we go back to 24, we're going to need a little bit of room for this. If we think about the factor set of 24, we know we have 1 and 24. We know we have 2 and 12. There's 3 and 8. And then there's 4 and 6. And I squeezed it in there. I almost ran out of room. I'll add in the curly brackets just to make sure. Okay. And so the factor set of 24 in this case is 1, 2, 3, 4, 6, 8, 12, and 24. Okay. We're also going to talk a little bit more about a couple other topics. We're going to talk about a prime number and then prime factoring. And so let's talk about prime factoring really quick. Oh, sorry, not prime factoring. Let's talk about prime number really quick. So earlier before, I said that there are several numbers that have multiple factors. A prime number is exactly the opposite of that. It's a number that has very few factors. In fact, the fewest it can possibly have. And in this case, we call those numbers prime. So a prime number, and I'll go ahead and type this out. It is stated a natural number is prime if it is greater than 1 and its only factors are 1, and itself. Okay? So, let's think of an example of this. Let's think of 5. So if we look at the number 5, right, the factors of 5 are 1 and 5. Okay, that's the entire factor set. We don't have any other two numbers, any other two natural numbers that when multiplied together get us to 5. So it's just 1 times 5. In that case, 5 is considered prime. Okay. Additionally, if we choose another number, such as 7, we see that the two factors for 7 are just 1 and 7. And so in this case, this is also prime. Okay. Now, what's the opposite of prime then? The opposite of prime is the two numbers we had above, which were 10 and 24. And in that case, we say 10 and 24 are composite. Okay. And so a composite number is very simply put, actually, in terms of a definition. So a composite number is simply a number that is not prime. Simply what it is. So if you take the definition of prime and then you reverse it, you get a composite number. Now, there is a special case, and it's an edge case in a way, but a special case is for 1. 1 in the number set, good old 1, that is not considered prime or composite. It's not considered either of those. And there's not really an easy reason for that, but we just don't consider it prime or composite. And it's not something for algebra that you would really need to be worried about. Now, after talking about prime numbers, we're going to talk about prime factorization, which I think is the greatest application of factoring that we have here. So I'll move on to prime factorization. And it can be kind of challenging at the beginning. I actually kind of find it to be a little bit of fun. I'll give a definition first. So prime factoring is the rewriting of a natural number as a product of its prime factors. Now, what are prime factors in this case? Prime factors are numbers that are prime, basically the factors that are prime. So we're going to look for all the factors that are prime. And one way we can use this, or one way we can do this, find the prime factorization, is by a factor tree. You may have seen this before, and I'll show it to you here. But if we take our favorite little number 24, I'll use something larger this time. So if we choose 24, when we do a factor tree, we draw these two little lines and we say, all right, what two numbers multiplied together get us to 24? Well, from our factoring, from what we did above, we know we have two numbers, 4 and 6. You can choose other ones, but for this case, I'll choose 4 and 6. Now, at this moment, we now need to repeat the process for 4 and 6. So what two numbers get us to 4? Well, we can choose 1 and 4. 1 times 4 gets us to 4. But does that really help us? No, we're left with a 4 again. So let's choose a different number. Let's choose 2 times 2. So 2 times 2 gets us to 4. And for 6, we have 2 times 3. Once we get down here to these two numbers, we then repeat the process again. We say, are there any factors that when multiplied together get us 2? Well, we have 1 and 2. But that's the prime factorization. These two numbers, 2 and 3, are both prime. So at this moment, we're done. Once we've gotten down to only prime numbers, which in this case we have a 2, a 2, a 2, and a 3, we then have the prime factorization. So in this case, the prime factorization of 24 is 2 times 2 times 2 times 3. And we'll go ahead and do one more, and then that'll be it for this video. We'll choose the number 40 now. So 40, a little bit bigger, and we'll take the prime factorization of this. There's multiple ways you can do this, and I encourage you to look at it on your own, or try a different set of numbers to begin with, but I'm going to choose 4 and 10. 4, we already know that we can choose 2 and 2. And then 10, we have a few options. We can do 1 times 10, but that won't help. We can use 2 times 5. That will help. And so now we have 2 and 5. And so then our prime factorization of 40 is 2 times 2 times 2 times 5. And that'll be it for this video.